Assalamualaikum and good day to everyone. Today we continue our new topic on equilibrium of a rigid body. The objectives of the lecture today are: number 1, you should be able to explain the conditions of equilibrium for a rigid body. Number 2, you should be able to sketch the free body diagram for a rigid body. And number 3, you should be able to solve the rigid body problems by using equations of equilibrium. Before that, we next to study what is the condition for the rigid body equilibrium. So here, what is the main difference a particle and a rigid body? So, number 1, particle. It is an object model. It is an object, okay, model as a particle. Okay, number 2, it has a mass, but we neglect the shape and size. Number 3, for a particle to be equilibrium, sum all of force acting on the particle is equal to 0. So mean that summations of force is equal to 0. Now refer to the rigid body. So what is the rigid body? A rigid body is the complex level in the modeling of an object. It is a composition of particles, many particles. And number 3, it can be any size of shape to existing model of a particle. And then it can support moments. And then also it have a support present translations of body in particular direction, that the support exerts on force on the body in that direction. And then if rotation is prevented, then the support exerts a couple moment on the body. So that is the difference. What is the particle and rigid body? Before we study a lot on particle, now we focus on rigid body. Right, next. What is the condition? Okay, you may refer to this figure 1 and this is figure 2. So what is the difference between figure 1 and figure 2? So this figure 1 show, so this is the particle. So normally force on a particle is concurrent, right? This is concurrent. Now we look into the force on the rigid body. Look at the force on the rigid body. So in the rigid body, the force are not usually concurrent because it may have cause rotation of the body, which means that due to movement created by the forces. So therefore, for a rigid body to be in equilibrium, the net force as well as the net moment about any arbitrary point O must be equal to 0. So means that summations of force equal to 0, which means that no translation. And also the summation moment at point O is equal to 0, which is no rotation. Okay. Next. Now we want to know what is the equations of equilibrium for 2D. So we have a short name here. Equations of equilibrium become EE. So when I mention EE, EE means equations of equilibrium. Now for 2D. Alright. So for 2D, a rigid body is subjected to a system forces which lie in X and Y axes. So here, for X and Y axis, we can resolve into I and J component for equilibrium. So when we resolve to the I and J, means that we have summation force in X equal to 0, and then we have summation Fy is equal to 0, and then we have summation moment at point O is equal to 0. Right? Right. Next, we have two alternative steps here. Okay, number 1, if the line passing through points A and B is not perpendicular to the A exit. So we can have here summation F is equal to 0, summation moment at A is equal to 0, summation MB is equal to 0. Alright, and second alternative, if the point A, B and C do not lie on the same line. So this one, we can assume that summation moment A is equal to 0, summation moment MB is equal to 0, and then summation MC is equal to 0. So in order to understand more, so we can see it when we doing the example, okay? Okay, here, when the body is subjected to a 3D force, equilibrium requires that the resultant force, summation force equal to 0, and the couple moment equal to 0. So this equation can be written in terms of x, y, and z. Also for the moment, so we have in x, in y, and in z. So this means that we have 6 scalar equilibrium equation that we can solve respectively into the axis. Summation f is equal to 0, summation fy is equal to 0, summation fz is equal to 0, and also summation moment mx equal to 0, summation moment my to 0, summation mz to 0. This is for the 3D cases. So now take a look why we need to study the rigid body equilibrium. Okay, for this figure show that we have a uniform ram. Okay, this is ram has a weight of 400 pounds. Okay, normally when we should understood when we have the weight for the ram, so where is normally the weight is acting? You must remember that. Where is acting? Centron of the body. So this is the center of the body. So this one we label as W weight. Okay, number 2, the ram is pinned at A and held in the position by the cable. So now we have pin. So pin is one of the type support reaction. Okay, this is pin here at point A, and then we have cables here. So when we have cable, we need to know what is the tension in the cable. So for this case, how can we determine the force acting at pin A and force acting in the cable? So we need to draw the free body diagram. How we can do that? Right. Now refer to this figure. So from this figure, we need to transform into this free body diagram. So FBD means that free body diagram. So in the free body diagram, what you should mention, what you should sketch. So you need to sketch the ram. This is the ram. Okay, this is the ram. Okay, all right. Now, the question mentioned that you have the self weight. So self weight W must acting at the centron like this, 400 pounds. And then we have tension cable here. So in the free body diagram, we must show this is the tension. Don't forget to label. Okay, and then we have pin support here. So what is the pin support? You may refer to this. This is the pin support. So when we know this pin support, so we need to know how many reaction at pin support. So pin support, we have 2 reaction, one vertical and one horizontal. So this is what is the free body diagram that you need to sketch before you solve the rigid body equilibrium. Right? Understand? Okay, next. This is another example which we have a cantilever beam here. This is the beam 6 meter, and then we have support at point A. So at support at point A is a fixed support. Alright, now also we have point load here. So this is the point load. So how are we going to sketch the free body diagram? Okay, number 1, when we sketch the free body diagram, you just make a line, right? So After you make a line, then you need to identify what is the external forces or any moment or any applied load. And then you need to identify what is the support reaction, and then do they give you the safe weight of the body or not. If have, you must show. Okay, number 1, must remember the safe weight must acting centroid of the body. So let's say we have a 6 meter here. So the centroid must be at 3 meter, this point. And then we have applied load here. So applied load, we just write back the applied load 1,200. And then here fixed support. So fixed support, we need to identify how many reaction for fixed support, this one. So here we have 3 reaction. So fixed support, we have 3. We have vertical, we have horizontal, and 1 moment here at point A. So this is how you should do, okay, when you want to solve the problem. Okay, next let's we study what is the characteristic for the free body diagram. Okay, FBD number 1 is the best method to represent all the known and unknown forces. Number 2, FBD means you need to sketch the outline only. Okay, outline. So it means that you can isolate the surrounding. And then number 3, you need to show all the forces and couple moment that the surrounding exert on the body, so that the effect can be accounted for the equilibrium condition. Okay, so now based on this slide, we can identify the support for the rigid body subjected to the 2D. Okay, for this number 1, figure number 1. So figure number 1 here, we have cable. So if you have this case, this problem, so you need to identify. So for this cable, how many unknown? So we have 1 unknown. So where the unknown acting? So direction is the tension force which act away from the member in the directions of the cable. Okay. Okay, number 2, we call it as a weightless link. Okay, this is the weightless link. So actually, this is one of the support, but we can ignore this one. So we only consider the weightless link here. So how many unknown force for the weightless link? So weightless link also have 1 unknown. So this unknown acting, okay, along the axis. So you can have the force like this or also like this. Alright, okay. And the third one. The third one is the roller. So how many unknown? So roller also have 1 unknown. Where is acting? So directions of force which act perpendicular to the surface of the point. So because here the first you need to identify the type of connection or the support, and the second, after that, you need to identify how many unknown. Okay, and then the third one, you need to know where is the action, reaction. Okay. Okay, here figure 4, we call it as a roller or pin in confined smooth slot. Okay, for this case, we also have how many unknown? We have 1 unknown. So this unknown also direction force acts perpendicular to this spot. Okay, to this slot. Okay, you can have like this and also like this. Alright, next we have roller here. So roller means that we have 1 unknown. So this force reaction acts perpendicular also to the point. And then this figure, we have smooth contacting surface. So if like this, we have also 1 unknown. So this unknown also act perpendicular to the surface of the point contact. And then this figure, with this figure we call member pin connected. So you must beware, this is the member pin connected. So how many unknown? So we have one unknown. So this unknown also at perpendicular to the road. So it can be like this and also like this. Alright. And then this number 8, we call it as a smooth pin or hinge. Okay, this pin or hinge have two unknowns. Okay, so these two unknown may have the component in y and component in x, or you can resolve as a coplanar if you have the angle here. Okay, and then the number 9 figure, we call it as a fixed connected. Just now we have member pin connected. Okay, look at this. This, if we have a fixed connected, we're going to have two unknown. So one is the distraction force and another one is a moment, which is x perpendicular to the road. And then the last one, we have fixed support. So this fixed support, we're going to have three unknown. So we have one moment here. Another two is the reaction in y and reaction in the horizontal x. Okay, or you can have this coplanar lah. Okay, this is the force and this is the angle and this is the moment. Okay, so this is the type of support or connection for the 2D cases. So you have 10 types of connection. You must remember this kind of thing. Alright. Alright. Now, why we need to have the support reaction? Okay, why we need the support reaction? Because the support prevent the translations of a body in a given direction, then a force is developed on the body in the direction, which is number 1. If rotation is prevented, so a couple moment is exerted on the body. And then consider the three ways a horizontal member beam is supported. Okay, commonly if you are a beam supported, so beam supported commonly can be supported by the roller or cylinder, and then number 2 can be supported by pin connection, and then number 3 can be supported by the fixed support. So means that these three things commonly support for beam, right? You must remember that. Okay, this is the example for the support reaction. This is roller. Still remember, So when we have roller, so we can have one unknown. So this unknown is at perpendicular to the point. So this roller prevent the beam from translating in vertical direction. Okay. Okay, and the second one, pin. So you can have this figure, or you can have this figure, or you can have like this, if you have the example. Alright. So this one, after you identify the type of support reaction, then you need to know how many the unknown forces. So for this pin, we have 2 unknown forces, which means that this reaction, okay, prevent translation in horizontal and vertical. Okay, and then this one is support reaction. So this support reaction have 3 unknown. So means that this support prevents the translation and also the rotation. Translation in what? Translation in x, translation in vertical, and then moment prevent rotation of the beam. Okay, so this is the type of connection for the real life. Okay, so this is number 1. Number 1 is cable exert force on the bracket. Okay, number 2 is a rocker. Okay, rocker support for the bridge girder, allow horizontal movement so that the bridge is free, expand and contract due to temperature. And then this one is a concrete girder, rest on the ledge that assumed to have a smooth contacting. And then this one is a utility building is pin connected on top of the column. And then this one is the example of the fixed connection. Okay, floor beams of the beam of the building are welded together and thus form fixed connection. Okay, so what is the external and internal forces? So why we need to put in the free body diagram? A rigid body is a composition of particle, okay, and then we have both external and internal force. So for free body diagram, internal forces act between particles which are contained within the boundary of the FBD. And then number 3, particles outside this boundary exert external forces on the system and must be shown on the free body diagram. And then the last one, free body diagram for a system of connected body may be used for analysis. Okay, so the weight and the center of the gravity. So you must understand when a body is subjected to gravity, each particle has a specific weight. So for entire body, consider gravitational forces as a system of parallel forces acting on particle within the boundary. So you can present the weight by W. Okay, and then when you define the weight W, you need to find the location. So the location of the force must be central of the body. Okay. So this is for the what is the idealized model. So and then okay, this is the example of the idealized model. So this is the real structure. So this real structure and this is the idealized model. So here this truss, okay, is represented by these forces. This one is this one, and then this one is this one. Okay, this is the beam. So this beam, okay, this one means that pin support, and here means that roller support. So this is meant by the idealized model. Okay. Alright, so this is another one. So you have here, you consider this boom supported by the pin. So this is the pin at point A and point B. And then we have BC as a weightless link. Alright, so now we have the loading here, point load here. Okay, average dimension used to specify the location of load and support. Alright, so before we solve the problem for the rigid body, so we need to know what is the step to draw the free body diagram. So we have 3 steps here. Okay, number 1, you need to draw outline shape. Okay, so imagine body to be isolated or cut free from its constraint, so you can draw the outline. Number 2, after you draw the outline, you must show all forces or couple moment. Couple moment means that moment. Okay, here you need to identify all the external forces or couple moment that act on the body. Okay, and then you have any applied loading. Okay, and then you need to identify directions occur at the support. Okay, or point at the body. And then you need to identify also, is it the question give the weight of the body. So to account for all the effect traced over the boundary, nothing is force and couple moment acting on it. Alright, and then the third one, identify each loading and dimension. Okay, so for this example, we need to draw the free body diagram. So how to draw this free body diagram? So this is weight. Okay, the weightless link lah, the spring attached. Okay, so we have the operator applies a vertical force on the pedal so that the spring is stretches 1.5 inch and the force in the short link at B is 20 pound. Draw the free body diagram foot pedal. So now you can identify. Alright, at point B here, we have a link here. So link we have how many unknown? We have 1 force here, and then spring. Spring also you have 1 force here, and then this one. This is what is the connection here. So here is pin, right? So how many unknown if pin? So we have 2. So we have vertical and also horizontal. And then the last one, don't forget we have the point load here. Okay, so don't forget that. Okay, so this is the free body diagram. Alright, okay, next. Okay, let's draw the free body diagram for this platform. Alright, so this platform has given mass 200 kg. So 200 kg. So when you draw, okay, so this is the idealized model. From here become here idealized model, and from the idealized model we draw the free body diagram. Okay, so this is you draw the platform. This is the platform. Okay, so this platform we need to identify the external forces. So now we have cable. So when we have cable, we have one unknown. So you must label T, tension, force. And then we have mass, right? So we have mass. So mass, when we calculate W is equal to mg. So mass 200 times 9.81. So mass acting centroid of the body. Okay, so this is the G lah. The question of the G. So this is the mass. Okay, and then we need to know what is the connection here. So we have pin. So pin we have two unknown, vertical and horizontal. Okay, other than that you should know lah the angle and then also the measure, the dimension given. So you can write into this free body diagram. Okay, before we continue to the example, so you need to identify also in order to simplify the equations of equilibrium. So we have 2 force members and 3 force member. It's a very simple. So you can refer to this figure. So this figure we have 2 points. We have point A and we have point B. So we have force. We have force at A, FA, and then we have force at B, FB. So this force FA and FB is a equal magnitude but different position. Means that it have same magnitude but opposite direction. So we can rename it as a F. Rename it as a F. So you can consider, okay, you can consider to calculate either at this point or this point. So that is the meanings of 2 force members. Okay, so take a look at this example. So this link you have point A, point B. So you can sketch like this. So we have the FB and FA. So you can simplify as F. Okay, also like this. Okay, alright. Okay, after this let's do the example. Here we have 3 important notes to be highlighted. Number 1, if there are more unknowns than the number of independent equations, then we have a statically indeterminate situation. So we cannot solve by this method. Okay, number 2, the order in which we apply equation may affect the simplicity of the solution. Okay, for example, if we have 2 unknown vertical force and 1 unknown horizontal force, so which one we can solve first? So of course we have to solve the unknown horizontal. So we can take summation fx equal to 0. And then number 3, if the answer for unknown comes out as a negative number, then that means the direction of the unknown force is opposite to the assumed. Okay, so you must remember this 3 thing, right? Alright, so before that, we have 3 steps for solving 2D equations of problem. Alright, number 1, if not given, establish a suitable x and y coordinate system. Number 2, draw the free body diagram of the object under analysis. Number 3, apply the 3 equations of equilibrium. What is that? We have 3 equations for the 2D problem. So we have summation fx equal to 0, summation F1 is equal to 0 and summation moment about a pump is equal to 0. Alright, now let's do example 5.1. So here we have the 4 kilonewton load at point B. Here at point B of the beam is supported by pins at A. So here we have pin at A and C. Supported by pins at A and C. This is also pin. Alright. So determine the support directions at A and C. Alright. So in order to do that, you need to draw the free body diagram. So the first step mentioned here, is given the axis? No. So the first step, you need to establish the axis. So now you may assume, okay, like this. So this is X, this is Y. Okay, number 2, can you find any two force members that can be simplified to our rigid body equations? Yes. So now this one, right? So here we have here this one, this member. So these members, we have this force or this force, right? Okay, and then we need to identify if we have pin support. Okay, how many unknown for pin support? 1 or 2 unknown. So for pin support, we have 2. We have horizontal and vertical. Then after you have identified everything, then you can draw the free body diagram and apply the equations of equilibrium to solve the support reaction at A and C. Okay, let's draw the free body diagram. So based on this figure, okay, you need to start from like this. So here we have beam. So beam, you just write one line like this. Okay, and then this one we have the loading, point load. You write point load. And then don't forget the unit, 4 kilonewton. And then here, this one, force members. So force member here, point C. Okay, only one. And then here, support. So support direction, we have vertical. We have horizontal. Then you can label everything. You label this one AX, this one AY. Okay. Then we have this one we can have, okay. So here you can have FCD for this force, and then this point B, this point C, and then this point A. And then don't forget the dimension. So dimension here, don't forget 1.5 meter. And also, because of this is the coplanar, so we need to determine what is this angle. Right? We need to determine the angle. So y is 45 degree because of this length. Okay. So after we draw the free body diagram, then we can identify how many unknowns do we have here. How many unknowns? So we have 3 unknown. Okay. Right. So now, from this free body diagram, we need to choose. Okay. Which point we want to take a moment is equal to 0. So always, okay, the key here, always take the maximum point. Maximum unknown. Maximum unknown. Okay, so for this case, which point have maximum unknown? So we have point A, because point A have the AX and AY. So that's why we take moment at point A is equal to 0. So for this example, we write summation MA counterclockwise positive is equal to 0 is equal to FCD. This one FCD. So FCD will resolve into vertical. So FCD sin 45. This one FPD times 1.5. Okay. This one 1.5, right? Distance. Force time distance. Moment, force time distance. Okay, and then we have another point here, point load here. So this one going like this, moment, right? So this point for negative, right? Because of the moment become negative. So negative 4 times distance. So distance is 3. So this one negative 4 times 3. So when we sum up, FCD is equal 11.31. Okay, after we determine the FCD, then we can determine others unknown, which is AY or AX. So now we want to determine the AX. AX we can apply summation Fx positive to the right is equal to, okay, now we have choose, okay, we select all the horizontal forces. So now we have AX, okay, AX positive to the right. So AX plus this one FCD coplanar resolve into X. So we have FCD now we get 11.31 cos 45. Right, this one. This is the FCDX lah in horizontal. So when we solve, we can solve that AX is equal to negative 8 kilonewton. And then we apply summation Fy positive upward, okay, is equal to, okay, now we choose, we select the vertical force. We have here AY. So AY plus this one, FCD, right? So FCD sin 45 and then this one minus 4. So we can solve that AY is equal to negative 4 kilonewton. So the answer here is negative. So negative means that the assumption that we assume first is opposite. Is opposite. Okay. Alright. Okay, so now we move to example 5.2. So the example 5.2 here, the beam is supported by the roller at A. So A roller and pin at point B. So the question determine direction at point A and point B. So definitely we need to draw the free body diagram. Before that, we need to identify how many unknown at point A. Let's guess. Point A is roller. So roller we have one unknown acting perpendicular to the point. And then at point B, how many unknown? We have 2. So for P, we have 2 vertical and also horizontal. Alright. Do we have any any 2 force member or 3 force member? We don't have here. So you can draw the free body diagram. Okay. Now we carry on to solve the moment, right? Okay. So here, what we have here is we want to draw the free body diagram. Okay, before that, we need to resolve this UDL, right? So this UDL, the W is equal to 3 kilonewton per meter. So now, how we going to reduce? We want to find the resultant force or point load from the UDL. So definitely, how to determine the magnitude? So the magnitude is equal to area of this rectangular. Okay. So where it's acting? So normally, the UDL, the rectangular UDL, acting at the middle of the beam. Right, centroid, acting centroid, right? So the magnitude become area 3 times 4 is equal to 12. So acting middle of the beam, so 4 divided by 2 become 2. Right. So now we can draw the free body diagram. So now you just like this here. Okay. So this one our axis Y and X, right? X, Y. So this one is our beam. Just make a line. Okay. This one is, and then another one. Okay. So we have the line here, and then don't forget to we have at point B here, we have two reaction. We have a by and also we have a bx. Okay, and then also at point A here, just now point B. At point A here, we have one reaction which is acting perpendicular to the point. So here we have a coplanar NA, right? NA. So when we have here is 30 degree, so here also become 30 degree. Okay, we're going to use the angle when we want to resolve this NA to the moment, to become the moment. So here we're going to divide it to coplanar after this. So here we have a component y and component x. Okay, after this. Okay, so now don't forget the measurements of the dimension. So here we have point load 12 kilonewton, locating at middle of the beam here, the line. So we have 4 meter, and then here we have 3 meter. Don't forget to put into the free body diagram. Okay, so now how many unknown do we have? So we have 1, 2, and 3. Okay, so in order to solve the unknown, so we need to choose which point to determine moment as a 0. So we need to choose the maximum point that to have moment. Means that here, which point? So we have point B, right? Because point B have the maximum unknown reaction. So that is why here we write summation MB counterclockwise positive is equal to 0 is equal to. So we need to resolve all the forces to become moment. So must remember moment is equal to force times distance. So now we start with the NA. So why here is negative? Because NA, okay, this is the NA, but we resolve into this one. So because when we want to calculate the moment, it's become counterclockwise. No, it's become clockwise. So this one become negative. Alright. So NA cos 30, because this NA we resolve into component Y. This one, right? Okay, now we need to know what is the distance. The distance from here, from the first to this point B. What is this distance? So we need to get the distance. That is why we need to resolve this 3 meter into this distance. So we can resolve, right? So this distance is equal to what? 3 cos 30. 3 cos 30. This one. So this is the distance for this force. So NA cos 30 times distance 4 plus 3 cos 30, and then minus. So this one minus, because this is another horizontal here. So NA sin 30 times distance. Okay, this distance, right? So this distance is 3 meters sin 30. Right. So and then this one plus this one point load here. So this point load 12 go to this point B. So 12 go to the point B become plus, because it's acting counterclockwise. So this is plus 12 times 2. 2 is this distance. Alright. Okay. So after you solve, you determine that NA is equal to 3.71 kilonewton. Right. Next, we want to determine the point B, unknown reaction. Okay. At point B, we want to determine the, let's say, BX. So BX, we write summation Fx to the right is equal to the positive is equal to. So we have to resolve all the force in X. So what we have here? So we have here, right? We have the NA sin 30 here. So NA is the 3.713 sin 30 minus this bx. So this bx. So bx become 1.86. Okay. Another one, by. So by, we write summation fy positive upward is equal to this one. We dissolve all the vertical forces. This one, 12, and by. Right. So we have NA 3.713 cos 30. Okay, minus 12 because it go pointlet go downward, and then plus B1 because it go upward. So we can solve that. B1 is equal to 8.78 kilonewton. Okay, so we can determine the support reaction at point A and also at point B. Now we determine the support reaction at A and B for the example 1.3. Right. So now we need to identify this beam is supported by what? Okay, now at point A. So point A is a roller actually, and point B is a pin. So in order to do that, you need to identify. Okay, how many unknown here? So here we have 2, and then here we have 1. Okay, can you draw the free body diagram in order to solve the problem? Okay, so this is the free body diagram. Right, so here this is the unknown for point A and Y, and then this is unknown for point B. Okay, this one because of we resolve the coplanar force. Alright, so here which unknown you can solve first? So definitely you may solve for the AY by taking what? Moment at point B, right? Because point B have the maximum point. So means that you need to solve the summation moment at point B. Positive is equal to 0 is equal to what? In order to get the AY. Okay. And then after that, you can solve. Okay. So after that, you can solve for the BY and PX. So this is the answer. AY 3.19, and then BY 4.405 Newton, and then BX is 424 Newton. Okay, I hope you can do this. Alright. Okay. Okay, the next example 5.4. Determine the support reaction at A and B. So what is the type of support at A? A is pin, right? So pin you have 2 unknown. And then B, you have how many unknown you have? 1, right? Okay. So here you have a point load here, and then you have acting moment here. So which point you can solve first? Definitely at B, because you can take, okay, which point is have maximum unknown? Definitely at A. So you may take summation moment at A is equal to 0, then you can solve at point B. Okay. So this is the free body diagram. Then this is the answer. NB 200 Newton, AX 100 Newton, and AY 233. So I hope you can solve. Okay. Okay, the last example 5.5 is determine the support reaction at A and B. Okay, now we identify here. So what is type of support at A? Pin, right? So pin, how many unknown? Support reaction at B, how many reaction? We have 2. B, what type of support at B? B is a roller. Roller, right? Smooth surface. So we have 1 here. So we have 3 unknown. Okay. So which point you can solve? You can take as a moment equal to 0. Definitely at A, because A have maximum unknown. Alright, I hope you can draw the free body diagram and you can solve the support reaction at A and B. Okay, so this is the free body diagram and this is the answer. MB 436 Newton, AX 268 Newton, AY is 286 Newton. Okay, that's all for today. Hope you can achieve the outcome of the lecture. Number 1, you should be able to explain the conditions of the equilibrium of the rigid body. Number 2, you should be able to draw the free body diagram. And then number 3, you should be able to solve the rigid body problem by using the equations of equilibrium. See you for the next lecture. Bye.